Hi everyone and welcome back to Physics 2A. I'm going to go ahead and get started here with the topic of fluid statics. First of all, we need to understand the different phases of matter. And maybe you guys have learned this in a chemistry class previously, but I'm going to go ahead and quickly go over the different phases. So the first one is solids, and solids have a definite shape and a specific volume, okay, like this in figure A here. Okay, and this is what we've been really talking about a lot this semester, are different solids and these motions of these solids, okay? Then we have something else. We have liquids, gases, and plasmas. Liquids do have a definite volume, but their shape changes depending on their container. So think of a liquid as like water. Water has a definite volume, but it does change shape depending on the container you put it in. So if you put it in a glass or a different, maybe like a vase or something, it's going to change shape according to that container. Okay, so this is your liquids here in B. Then we have gases that don't have a definite shape or specific volume, and their molecules move to fill whatever container it is in. Okay, so think about if you're in a room and there's oxygen all over the place. It's not going to just sit in the corner. Okay, the oxygen is going to fill that space. Okay, so it's going to fill that complete room. Okay, spreads out. And that is like in C. And then we have something called a plasma, and that does not have a definite shape or a specific volume. A lot of times we look at plasmas in astronomy because that is what is in a star. So we won't really touch on that much, but just to get the idea out there. Okay, and this is the idea of D here. Okay, but just notice the difference between all of these phases of matter. Okay, notice their types of motion, okay, that they're having. As you can see in A, this solid, these kind of just vibrate back and forth. They don't really go anywhere, these atoms, okay? Then when you get to B, they start to flow around more freely, but they are going to be contained within whatever container you have it in. And then in C, you can see gases, and even with plasmas, they're moving freely about, okay? You can also notice that they have a different, I would say, velocity, okay? So you can't really just see that, but in a solid, these atoms aren't moving much, okay? They're barely moving, and then in a liquid form, they, again, like I said, move freely, right, within a container. Now think of this as maybe ice versus water, okay? Now ice, when you freeze water, right, you get ice, and that ice is just stationary. It's not going anywhere. It's a complete solid. As you add heat, and this is kind of getting ahead of ourselves, but just kind of getting the idea out there, we get back to water, right? Something melts, our ice melts, and we get back to water. Okay, so as we go along with these different phases of matter, we're going to be getting a higher amount of heat as we go, okay? Think of ice and then room temperature water, okay? Again, this is not the huge point of today's lecture, but I just wanted to kind of get the idea out there of the different phases of matter, and we will talk about this eventually, okay? So let's go on and start talking about fluids, which is what we are looking at right now. Okay, and fluids are going to be any liquids, gases, or plasmas, okay? And what makes them fluids is that they yield to shearing forces, okay? While solids resist shearing forces. And what is a shearing force? A shearing force is any kind of force that's moving in one direction and in another direction, okay? And a fluid can just kind of flow by, no problem. But with a solid, if you have a shearing force in some different directions, it's going to resist it. It doesn't want to move, okay? But with fluids, it can kind of just get moved around, right? Think of when you maybe put your finger in water, the fluid just kind of moves out of the way. But if you try to do the same thing with ice, the ice isn't going to move, right? So again, we have the fluids, I should do that, versus the solids, okay? All right, so another thing about solids is that atoms are in close contact with forces between them, and that allows the atoms to vibrate, like I just showed in the last slide, but they can't change positions with neighboring atoms, okay? So like in this figure, these atoms are moving around, okay? They're kind of oscillating next to each other, but they won't change positions, okay? So they won't switch with each other. Versus in water and these other fluids, they can change position, kind of switch around, move around freely, okay? All right, another way to say that is that they flow, okay? Fluids flow, okay? Now, I do have this link here. This is the first section in your textbook. Let me bring it up real quick. Okay, and this is what we're looking at. I just wanted to kind of show you guys. This is at the bottom of section 11.1, and it's a PhET. Interactive simulation, but just to look at the states of matter. Okay, so we've got solid. Okay, so like an ice cube. We have liquid, which would be like water. And then gas, we can say would be like water vapor, steam maybe, okay? And just, we can notice the difference with the molecule. Later on, we'll look at it in a bit more detail, but for now, just looking at the different states of the molecules, okay? So again, we have solids, they're vibrating. Liquid, they're kind of wiggling around, more motion, right? And then gas, they are all over the room, okay? Or this container, I shouldn't say room, the container, okay? All right, and you can play with it a little bit if you're interested. And they also have how they change and so on, but we'll get to that in another section, okay? All right, the next thing we need to talk about in terms of fluids or actually anything is this idea of density. Okay, density is not weight, density is not mass, it's different. Okay, so density is going to be the mass per unit volume of a substance or object. Okay, so again, it's density, that's what this guy is the mass over the volume of a substance. Okay, density, it is represented in this equation as a rho. That's how I draw it, okay? And it has the units of kilograms per meters cubed. So this is a density unit, okay? And I have this picture here, and this is to show you what density is. It kind of helps you get the idea. So that classic question of what's maybe you could say like what's heavier, a pound of feathers or a pound of bricks. Okay, and maybe you've heard this before. Okay, it's just like a funny joke or whatever, because you are asking what is heavier. Okay, and a lot of people would say, oh, the pound of bricks. But if we're talking about weight, right, because that's what heavier implies, that is going to be based on this here. Our weight is the same here. Okay, so they're both heavy. But when we're thinking about it, right, when we're saying, okay, what's heavier, I think a lot of times we're thinking of the density, okay? Because when you think of holding one feather versus holding one brick, the brick is much more dense, okay? It seems like it would be the heavier substance, right? Okay, so that's kind of a little sidetrack, but this is what we're saying, okay? So the density of two different things may be very different, okay? And you may, in order for them to be equal, so this is like we were looking at a week or so ago with a pivot here, right? Trying to do this balancing act, okay? In order for them to be balanced, we're going to need a lot more feathers, right? So we need more feathers than bricks here. Why is that? That's because the bricks have a higher density, okay? And the feathers have a lower density. So for them to get to the same weight, you're going to need more feathers, okay? All right, so this is just the idea of density, and we will use this in the next couple of slides here. Okay, so this first one, we have an example, and it states a reservoir has a surface area of 50 kilometers squared and an average depth of 40 meters. Okay. What mass of water is held behind the dam? Okay, and it states the density of water is 1.0 times 10 to the third kilograms per meter squared. Okay, so we want to know the mass of the water. We just found that the density equals mass over volume. Okay, and we can solve for our mass using algebra, and it's going to be equal to our density times our volume. Okay. Okay, and I'm not sure if this is an error or not. This says kilometers and this says meters. So we'll go ahead and have to do a quick, a quick unit conversion. Okay, so 40 meters is going to be 10,000 or 1,000 meters, and a kilometer. Okay. So just keep that in mind. Volume is going to be equal to length times width times height. Okay. It's the volume of a rectangular volume, maybe a cube, okay, or something like that. And so we already have the surface area, so that might be the length times width. Okay, and then the height or the depth is h. Okay, so we got kilometers squared times 40 meters, but we need to convert that. Actually, we need to convert this first one. Whoops. Okay, so like I said, we need to convert the first one, so let me go ahead and do that. And this is going to have to be squared since we have kilometers squared. So we have 1,000 meters per kilometer, and that's squared. And then times our depth, which is 40 meters. Okay, so we get our volume, and then we can find our mass. Our volume is 2.0 times 10 to the 9th meters cubed now. And so we take our density, 1.0 times 10 to the third kilogram per meters cubed. Multiply that by 2.0 times 10 to the 9th meters cubed. And so we get 1 times 10 to the third, 2.0 times